Welcome back, guys, to part 3 of creating a Pokemon game in Godot. In this video, we're going to take a look at creating our very first character, and this character is going to be our player. We're going to define a couple base classes for any character that we're going to have in our overworld, but specifically focus on our player. So we're going to have some things that will be shared and some things that will be specific to the player. By the end of this video, you'll have a fully animated player character that can move around the map and the camera will follow them. So much like the last video, you're going to need a sprite sheet for a character. You're going to want a sprite sheet that has each direction covered, like the one on my screen, where you can create animations depending on which way you're facing. Don't worry about the rectangular shape of these characters and that the pixels aren't 16 by 16. That's okay. Your character could be scaled down, and it's okay if it overhangs a little bit, and eventually we'll have some code that deals with that when it comes to layering things on top of them. If you're liking this video series so far, don't forget to like and subscribe, and if you're feeling real generous, you can support the channel by buying me a coffee. Okay guys, let's get into this video. Go ahead and open up the Godot editor, and let's get started. We can go ahead and create a new scene for a node 2D, and the first thing we're going to want to do is actually switch the type of this node. So you're going to go to the change type in the drop down menu after you right click on it, and the type we're going to change this to is a character body 2D. Now you'll notice with the character body 2D, instantly you get a little warning label here, basically telling you that there is no collision shape that has been created for this, so it can't actually collide with anything. Although we're not taking care of collisions in this video, we're going to set them up on the player side so that they're ready for the next one. What you want to do is add a child node underneath your character body 2D, and I'm actually going to rename this to player before I do that. And the child node you're going to want to add is collision shape 2D. Now you're still going to have a warning label because you actually need to define a shape. So let's call this collider, and then inside of our inspector, go ahead and create a new rectangular shape 2D inside of the collision shape variable. Once you've done that, a rectangle is going to pop up on the screen for you. So we're actually going to use the coordinate 0, 0 as the top left corner of our player. So what we're going to want to do is we're going to want to move this rectangle to cover the 0 to 16 in the X and the Y on our grid. If you haven't zoomed in already like I have, just make sure you do that now so you can actually see, and make sure your grid snap is on and set to at least 8 pixels so that you can move everything around. When your grid snap's on, you can drag the corners of the collision shape to the actual places they need to be. So the top left corner should be 0, 0, and the bottom right corner should be 16, 16. And don't forget to save your game. I'm going to save the player scene into a characters folder or an entities folder, whatever you want. Once we've done that, it's time to go ahead and add a couple more nodes underneath our player. I'm just going to search for a regular node, and I'm going to add 2 of them. One I'm going to name input, and one I'm going to name movement. The reason that these aren't node 2Ds is because these are just meant for handling different types of scripts, so they don't really need anything else other than to exist. Next, I'm going to add an animated sprite 2D, and this is what's going to control what our player looks like and control the animations for us to use. Like before, don't worry if you see this little warning label. That just means that it's missing something on the inside we need to create. In this case, we need to create some new sprite frames inside of our animated sprite in the inspector. Go ahead and create those, and then once you do, at the bottom, you should be able to see the sprite frames pop up where you would normally see the tile maps or the tile sets from the last video. You're going to see a default animation that's already created, and what we're going to want to do is create a bunch of new animations. In total, we're going to want to create 12 new animations, 4 idles, 4 walking, and 4 animations for turning. Similarly, they're all going to have down, up, right, and left, meaning that there's a direction for each of our actions. So there's an idle down, walk down, and turn down. Go ahead and create 12 animations and rename them. Make sure you have each direction for each action. So again, 3 actions, idle, walk, and turn, and 4 directions for each, up, down, left, and right. Now, once you've renamed them all, let's go to the top for our idle down and start filling out our animations. So how this works is you click on the animation that you want to fill out, so in our case, idle down, and then you're going to go ahead and hit the button that looks like a little grid called Add Frames to Sprite Sheet. Generally, when you do this and you select an image, and I have the player selected because I've already imported it. If you haven't done that, you should do that now. and make sure you put it in your assets folder. Once the window pops up, usually Godot is pretty good at separating out these sprites for you, so you can see it's already created my frames. And on the right hand side, it'll automatically fill in these settings for you and separate it for you. So you can see the actual size of this player is 32 by 48. We're going to scale that down in half, so it's going to end up being 16 by 24. Again, that's okay if it's going to be taller than it is wide. No problem. So for our idle down animation, all we really want is this first frame, this top left frame, selected, because that's what idling is. You're not doing anything. If your sprite sheet is more complicated and the player's maybe doing like a little dance or something when they idle, that's fine too. But for now, we're going to keep it simple and just select this. And once you do that, you can see that the imported sprite is already way too big. And you can see that we have to apply our filter nearest like we did for our tile map to get it to not be blurry. Go ahead and cut the player size in half, and then make sure the feet are where the bottom of your collider are. It's okay if the head sticks up a little bit, that's not a problem. Just make sure the feet are touching the bottom. Go ahead and fill out the next 3 idle animations with the appropriate tile from your sprite sheet. It should be noted that the looping action is on for idle. I mean, it doesn't really have to be because it's not moving, but you can leave this on for walking and idle. We're going to be turning it off for the turn directions. So for turning in the sprite sheet, what we're going to do is we're going to select in order of right to left 2 of the animations. So when the person turns, it's going to play a very brief animation. It's going to be hard to catch here when I turn off the loop, but you'll see that it moves very fast. Inside of the game, when you're turning from a different direction, it will look a little more clear. So for each of them, select the second column first and then the first column second. Once you've finished with your turn animations, it's time to do our walking animations. For these, you're going to select all 4 of them, but make sure you start with the second one first and then finish with the first one. Once you do that, go ahead and hit the play button to see what it looks like. And look at that, it looks like your player's walking. So it's pretty easy to actually get this up and running. Now that we've finished all of our animations, I'm just going to go back through and make sure they all look correct. Make sure that for all of my turn animations, looping is turned off, and make sure everything else looks good. So now let's go back to our player component and we're going to add our camera 2D. This camera will follow around the player. Inside the inspector, you can play around with the zoom and this will show up as a blue rectangle around your player if you zoom out. This will be how close the camera is to the player. There's another option I'm going to select called position smoothing, and that's because I want to follow the player, but when the camera hits a boundary that we're going to set up, you want it to just bounce around smoothly, not be all jagged. And you'll see what this looks like later in the video after we start getting our player moving. Finally, make sure you put the transform of the camera at 8x8 so that the camera appears at the center of the player compared to the player's position of 0, 0. And if you run your scene from the current scene, you'll see that when the game pops up, the player is right in the middle. So you can adjust your zoom levels accordingly. I'm going to go with this. Next, let's add a new component to our player, and it's going to be a collision raycast. So we're going to look for a raycast 2D. I'm going to rename it to collision raycast. And this is going to be responsible for detecting collisions. But before we move on, what we have to do is we have to position the raycast where we want it. So make sure your grid snap is set to at least 8 so that you can select the middle of the player, drag the beginning of the raycast to the middle, so it starts at 8, 8, and then take the end of the arrow and target it to where the middle of the next square would be, the next grid square, 16 by 16. Your target position for your raycast should be 0, 16. And we want to collide with areas and bodies, but we don't want to hit from inside because that will cause multiple collisions anytime we enter some sort of trigger that we create. So finally, the last thing we're going to add to our player is a new node. And we're going to call this state machine. We're going to use a state machine to determine what state our player is in, and therefore what controls we can use. We could put all of our control code into our input and our movement, but eventually with so many different scenarios in a game, your input, movement, interaction files can end up being thousands of lines long. So what you want to do is you want to find a good way to separate them. And for me, that is to have a state machine. Create a node underneath that state machine, and you could call this free state, roam, something that describes the player's actions when you're just moving about the map, not really doing anything in particular, just free roaming. I'm going to call it roam. Save your player, and then what you can do is you can actually go to your game manager scene and you can instantiate the player somewhere inside the map. Just make sure it's somewhere on the grass, and you can run this current scene to see what it's going to look like when you spawn into the game. So you can see here the player in the middle of a map, and this actually kind of looks like a Pokemon game now. Obviously, this is just very basic and nothing happens yet because we have to program everything in, but this is a good starting point. And really quick, I'm just going to rename my entities folder to characters just to kind of keep everything in line here. You don't have to do this step, but I just want everything to have the same name through code, through folders, everywhere. Now that we have all of our nodes set up, now let's actually attach some scripts to everything to get everything working. This is going to take a little while because we have a lot of initial setup to do, but the payoff is going to be awesome. Go ahead and right click on your input node underneath your player and create a new script. And we're going to throw this one in our scripts folder. And I'm going to make a new folder called characters to stay in line with the other ones. And I'm going to call this file playerinput.cs. Now, I know I mentioned before that players and NPCs and whatever overworld characters you have are going to share a lot of stuff. So I'm going to create this player input file first, and then I'm going to create some of the base character classes. Inside of our player input, we're going to want to just hold a couple of variables. The actual input isn't going to be done in this file as it normally would. We're actually going to do that when we create our state machine, but we still want somewhere to keep the variables that we need for input, and this is the best place to put them. I always like to put an export category. You don't have to, but it does make things easier to look at in the inspector. So for our player input, we're going to need two variables. I'm going to want something called my hold threshold and my hold time. Both of these are going to be doubles. They're both going to be public, and you can export them both so we can see them in the inspector. The hold threshold is how long we're going to be holding down one of our keys to make a player turn instead of just start walking. So if you only hold the key for a specific amount of time, in this case underneath 0.1 seconds, if you let go before that threshold, the player's just going to turn if you're facing a new direction. If the hold time is over the hold threshold, then the player's going to start walking. Inside of the ready function, I'm just going to import my logger and just say loading player input component. I'm going to do this with a lot of my components so you can see them all log in the console in Godot when we run the scene. Before we're done with this file, we actually have to put everything inside of a namespace. Since this is in the gameplay characters folder, I'm going to keep it simple and just do 2 levels for the namespace. I'm just going to put the namespace as game.gameplay and throw my partial class inside of it. And then that's all we need for the player input. So again, we're not going to actually be doing the input here. We're going to do it from a state. Let's go ahead and just copy this file and create a new one. We're going to call our new file character input. And this is actually what player input is going to inherit. So once you erase everything and rename it, turn this into an abstract class. I'm going to create another export category, and I'm going to call it common inputs. Inside of our common inputs, we're going to have 2 more variables. These ones are going to be vector 2s. One of them is going to be our direction, so the direction we're facing, and one of them is going to be called the target position. For now, you can set these both to be equal to a vector2.0, as these will be controlled in code. Next, we're going to add a couple things called signals. Signals in Godot is what a node can use to let other nodes know that something is happening. So instead of importing another node and controlling its functions through code, you can actually listen for signals instead. And whenever one of those signals is fired off, anything listening to that signal will trigger. You could declare signals globally as well, but we're just going to do this for now. The 2 signals we're going to have are going to be called walk and turn. To declare this in C#, you're going to declare a signal like you would an export and do a public delegate void, the name of your signal plus the name event handler. Event handler has to go on to the name in order for C# to recognize that this is a signal and treat it as such. Finally, go back to your player input, and instead of inheriting node, you're going to inherit your character input. Once you do that, you can go back to your project and hit the build key, not the play key, but the build key, just to refresh the inspector to grab your new variables. And you can see in the input component, you have the player input from the class that inherits. So you have your hold threshold and your hold time, and then you have your common input from the inherited class, direction, and target position. So this is working properly. Next, we're going to create a script for our movement component. So right click on movement, create a new script. drop it into the same folder as the other scripts and just call it character movement. We don't need to make a special player one for this one because it's going to share the character movement just the way it is. Go ahead and create a namespace, game.gameplay, put your partial class inside of it, and then you can get rid of the comments or you can just leave them for now, whatever you want to do. The first thing we're going to do is declare a signal, and that's going to be a public delegate void animation event handler. The character movement is going to be responsible for deciding when an animation is played, and the animation component will be responsible for picking which animation to play. Next, I'm going to declare some variables. I'm going to separate them with my export categories. This one I'm just going to call nodes, and I'm going to have a public node 2D character. This is going to be a reference to the actual player itself, the character body 2D that controls everything. For now, that doesn't really need a script, so I can just leave it as this for now. And then I can declare a public character input and just call that character input. In C#, you can go ahead and just name things the same thing as their class. This is a common practice in C#. If you're used to like TypeScript and Python, this may look a little funky to you, but this is totally okay. In another category, I'm just going to call this movement. I'm going to have a vector2 called target position, and the default target position is just going to be vector2.down. And then I'm going to have a bool called isWalking, and I'm going to set that equal to false. Eventually, we're going to have other bools to go along with this, but for now, we're just going to focus on walking as our type of movement. Inside of our ready function, you can go ahead and log that the player movement component is loading if you want to. Next, I'm going to create a function called public bool isMoving, and this is just going to check to see if my character is moving around. The reason I have this function instead of just checking isWalking is because in the future there's going to be other types of movement and we want to check them all. So for now, this just can return isWalking. Next, I'm going to create a function called startWalking. This is going to be called when we get the event to actually start walking from our input. First, we're going to check to see if we're not moving. If we're not moving, then we're going to go ahead and execute this code. I'm just going to put a little comment here to throw my walk animation in when it's time, but I'm going to skip it for now because it's not set up yet. For walking, we're going to set our target position, and that's going to be equal to our character position plus the direction times the grid size. If you remember from the first video, we declared our grid size and our globals, so that should import for you automatically. If not, you got to import it from the top. Next, I'm going to add some logging and say that my character is moving, and I'm just going to log the positions to and from. You don't have to do this part, but I like to do it to debug. Next, we're going to set our isWalking to true. And then finally, you can have an else block that will play the idle animation. I think I might play this from the actual movement itself, but I'm just going to throw this here just in case, and we'll clean it up at the end. Now, the actual thing that's going to be walking is our walk function. So create a public void walk that takes a double delta, and then check to see if we are walking. And if we are, we're going to make our character.position equal to, and that's going to be character.position.moveToward. And we're going to be moving toward our target position. And then we're going to be using float delta times our global instance grid size. And then I'm going to add ×4 just to try and adjust the speed a little bit. Now after this, what we're going to do is we're going to check to see if our character.position.distance2 as a function, our target position, is less than 1. What we're going to want to do is call our stop walking function. So this basically is asking, are we right on top of where we should be? We're going to stop walking. Quickly in an else block 2, we're going to play the idle animation here. I think this is where it's actually going to go. Inside of our stop walking function, we're going to set our isWalking to false. And then we're going to create one more function, and that's called snap position to grid. This function is going to ensure that we're always on our 16:16 grid system. Sometimes when there's collisions and other code in your game, sometimes your positions aren't exactly divisible by 16. Sometimes a float number comes up where it's like 15.999 or something like that. This function will ensure that we always stay on our grid system when we're not moving. And how we're going to do that is we're going to make our character position equal to a new vector2, and then it wants you to pass in new x and y coordinates. How you're going to calculate that is by using the mathf.round function. Inside of it, you're going to do your character position.x divided by the grid size, and then outside of that, multiply it by the grid size. And you're going to do the same thing for the y. This should ensure that we're always on our grid system. Finally, we're going to make one more function, and it's going to be called our public void turn, and all this is going to do is play our turn animation. Back in the Godot editor, it looks like I forgot to actually attach my movement script, so I'm going to right-click on movement and attach the script we have for character movement. I thought I did this already, but we'll just do it now. Next, inside of the inspector, on our character movement script, you can actually go into the variables and you can attach the player and the input. So now those are hooked up. Make sure you save it. Next, we're going to create a script for our animated sprite 2D. Go ahead and put that in the same folder, and you can name this character animation as well. Once you're inside your character animation script, you can go ahead and put it inside your namespace and get rid of everything on the inside if you want, and we can start inputting our variables. I'm going to create an export category called nodes, and the nodes that we need for this are our character input and character movement. Create a variable for each. Now, before we do anything else, we're going to go define a new enum inside of our enums file in the core folder. What this enum is going to represent actually is just a list of strings, and it's going to be the actual names of our animations. So turn down, turn up, turn left, turn right, all of the animations we gave our character before. I'm just going to make an enum list for them, and then when we want to actually call them, we can just use the toString function and then imitate the string. I'm going to call the enum my e character animation. I'm going to have other things named character animation. For example, my animated sprite 2D class is already called that. So I'm going to throw the e in front because this serves the same purpose, but it has to be a different name. So e stands for enum. Go ahead and fill out the enum with all of the 12 different animations. And then once you've done that, you can go back to your character animation. You can create a new export category called like animation vars or something like that, and add a new public e character animation and set that equal to the idle down enum. Idling down will be our default. Inside the ready component, I'm going to just add a little logging message like we've been doing. Now the next thing we're going to do is create our play animation function. So this animation function is going to be triggered by a signal from our character movement. So anytime we start a new movement, we're going to play an animation. So every time movement sends out a signal, play animation is going to be listening for that signal. We'll hook it up once we're done creating the function. Our play animation function is going to take in one string, and we're going to call this the animation type. This can be one of three variables: walk, turn, or idle, or at least for now, those are the only animations we have. So what we're going to want to do first is grab our previous animation, and we're going to declare a new variable called previous animation and set that equal to the current e character animation. Next, we're going to check to see if the character movement script is moving is set to true. If so, we're just going to return because we don't want to do anything if the character is moving. The animation for moving, walking, turning is going to be played before moving is set to true. So this should help stop any overlapping animations and any weird looking animations. We're going to add a switch case to the animation type, and we're going to add our three cases: walk, turn, and idle. I'm not going to have a default case because I don't really want anything to happen if it drops through all of these cases. Next, inside of our walk case, what we're going to do is we're going to check for our character input direction. We're going to check to see if it's up, down, left, or right. And depending on which one we get, that's the animation that we're going to set our e character animation to. So for example, our e character animation is going to be set to walk underscore up if our character input direction is a vector 2 up. Create the same case for all four, so down to down, left to left, and right to right. And then what we're going to do is something similar inside of turn and idle. Both of these cases is going to look almost identical to this, but all we're going to do is change it from walk right, walk down, walk left, and walk up to either turn or idle, depending on which switch case we're in. Now, once our switch case is finished, after it, we're going to have one more statement, and we're going to check to see if our previous animation is equal to our new eCharacter animation. If they're not equal, we're going to use the play function built in to the animated sprite 2D, and what you're going to pass in is the current eCharacter animation .toString. So this turns the enum into a string, and the play function inputs a string, and then it will try and play the corresponding animation. If you want, you can even throw a little logger.info statement in here and say that we're playing this animation. Head back over to Godot and build the project one more time. Your animated sprite 2D script should now have its input showing up. So what you're going to want to do is assign the character input and the character movement, just like we did before. Another nice reason here you can see using enums is that Godot automatically makes it a drop-down list whenever you have an enum as a variable. So now if you go ahead and play the player scene, let's see what happens. So you can see that all of the functions on the bottom here are being called, all the ready functions, they're loading, but that's pretty much it. It doesn't matter if I hit controls or anything. None of the signals are hooked up. Nothing's really working yet. So we still have a little bit of work to do. Let's go back to our scripts and see if we can hook up some of these signals. So first, let's go over to our character movement. Inside of our process function, you can go ahead and call the walk function that we created and pass in the delta. Walk is going to be called all the time, but will only work if we're actually moving. Next, inside of our ready function, what we're going to do is we're going to call our character input dot, and then what we're going to do is look for our walk signal, denoted here by this little lightning bolt. Even though it's called walk event handler, C# knows that this is just the walk event. So the syntax for this is going to be a plus equals, and then you're going to pass in the corresponding function. Now, if your function or your signal had input, this would look a little bit different, and you'll see that in a future signal that we put together. This syntax is very similar to JavaScript, as it kind of looks like a Lambda function. So the walk event handler is going to point to the start walking function. And similarly, the character input.turn is going to point to our turn function. If we go through our character movement script a little bit more, you're going to see that we have a couple to-dos here. So what we're going to do is we're going to actually start emitting some signals here. And right before we emit our signal, we just have to go back up to our signal at the top, our animation event handler, and we have to actually add our string, our animation type, because this is going to be attached to the play animation function inside of the animation script. So we have to make sure that this has an input as well. So you're going to type in emit signal, and then this takes in one or more inputs. The first input being the signal name. In our case is the animation signal. An interesting way to grab that signal name is you can type in the signal name class and then do .animation. It automatically picks it up if you have any signals declared here. So, or you could type in actually animation as a string, but this is much safer. And then if your signal has input variables, they're going to be the next argument. So we only have one, and it's just the type of animation we want. And in this case, it's walk. And in the else block, you can do the same thing and just call idle. Call the idle signal here in the walk function as well. And I'm actually going to get rid of it from the start walking function because we only need it in the walk function. So get rid of the idle after the is moving block. And then down in the turn function, you can call the turn animation. So now we have signals being emitted from our character movement going to our character animation, but we don't have any input signals that we declared in our character input, our abstract class, going to our movement. Instead of putting them in the player input, as we discussed before, we're going to program out some player states. So it's time to work on our state machine. Back inside Godot, right-click on your state machine and go ahead and create a script for it. We're going to put this one in a new folder called Utilities. The reason we're putting it here is because it won't be unique to characters. State machines can be used for anything, from a UI to a battle system to character states, etc. Go ahead and add a namespace here. We're going to do game.utilities. And now we're going to program out our state machine. We're going to need a couple of variables here. The first thing we're going to have is our public node, and this should be called owner, but owner's already a reserved keyword, so let's use the word customer. And then we're going to need the current state. So we actually have to define our state class now before we do anything else. So for our state class, it's going to be similar. We're going to add this to our namespace. We're going to do game.utilities. Inside of it, we're going to declare a public node, and this is going to be our state owner. So this could also be called customer if you want. And then we're going to have a couple functions that are virtual. So these functions can be called from the inheriting states, or they can be overwritten. We're going to do two. We're going to do enter state and exit state. You can log inside both of them. I'm going to put logger.info, and I'm just going to call the actual name of the state that's calling it. So how you do that is you're going to type in entering, and then as a variable, get type as a function .name. This will return the actual class name. So whatever inherits state, that's what it's going to return. I'm going to do the same thing for exit state and just say exiting instead of entering. Back inside our state machine, go ahead and add a public state, current state, and you can throw an export category up top if you want to as well. Inside of our ready function, what we're going to do is we're going to do a for each and then declare a node child in get children. So basically this will return a list of every node that's underneath the state machine, which will only be states. And we're going to check to see that if the child is basically a state class, this is the syntax on how you write it. So it's child is state state. What you're going to say is that the state owner is equal to the customer, and then the state.setProcess is going to be false. What this will do basically is turn off its process function. So the state is kind of just idling there, not updating, which means that the state is turned off. And what we're going to want to do is eventually turn whichever state we're in on. Next, create a function called public string getCurrentState and simply return the current state.name toString. Finally, we're going to create a change state function. And what we're going to do is pass in a state, call it new state. We're going to do current state, and we're going to add the question mark here just in case it's not equal to anything yet, .exit state. Our current state is going to be equal to our new state. And finally, we can call current state.enter state. This will call the enter state function, and if there's anything your state needs to do before it starts running, this is the function that's going to do it. Next, we're going to have another for loop just like we did inside of our ready function. The only difference is that instead of set process equal to false, what we're going to do is we're going to check to see if the current state is equal to the child that we're looking at. If it is, we're going to set the process equal to true. So now our state machine and state abstract class are ready to go. Our final step here is going to be creating the input, or creating the state for our player input. So first, let's go back to Godot and rebuild, and then take a look at our state machine to see its new properties. What you're going to see is the variables pop up. The customer, you definitely want to declare as the player, but the current state, it doesn't matter if you assign it or not because it's not going to be picked up automatically. What you're going to have to do is actually change the state when the game starts in order to give the player a state. You can go back to the state machine and basically take the second for loop we created and put that in the ready function, and that would actually automatically create the state and have it start running when the game starts up. So now it's time for me to create my player roam state. So I'm going to create a new script, attach it to my roam node, and call it player roam state. And this is going to go into the characters folder. And I actually might just put it in a states folder because there might be a lot of states by the time we're done this game. So let's separate them out. Again, this state should be basically named to make sure you know exactly what it's doing. So I know the player can just roam around in this state. Or you could call it like free state or something. But whatever the name is, it should reflect what's happening inside of it. As we always do, take your partial class and put it inside of a namespace. Game.gameplay in my case, but you can do whatever you want. Make sure that your player roam state inherits from the state class instead of node. And then we're going to create an export category. You can call it state variables or whatever you want. The only variable we need to add to this state is our player input. So you notice I'm not using character input. I'm specifically using player input since this is a player specific state. Go ahead and override the process function one more time. Let's bring that back in. I'm going to create two functions down below, get input direction and get input. Get input will take the delta, that's a double, from process. So first let's fill out our get input direction function. This function is responsible for figuring out which direction we're facing. So what we're going to want to do is basically just check whichever button has just been pressed directionally, that's the direction we want to face. The reason we're using isActionJustPressed is because we only want it to register when the button is pushed down for the first time, not when it's being held down or released. So we're going to do an input.isActionJustPressed, and then we're going to pass in a string, and Godot's identifier for the up direction is UI_up. So if our input action is just pressed is equal to UI up, this is what we have to do. We're going to make our player input.direction equal to vector2.up. And then we're going to make our player input.targetPosition equal to a new vector2. And it's going to be 0 and then minus our grid size. Up in Godot is minus in the y-axis. Similarly, for all of the other input actions, we're going to do the same thing. Depending on the direction, the vector2 for target position is going to change slightly. So for UI down, the player input direction is going to be vector2.down. And then the player input target position is going to be similar to up, but instead of a minus sign, it'll be a plus sign for the grid size in the y-axis. And then for left and right, it's going to be negative 16, 0, and then 16, 0. Now that we have that, it's time to get our input. Now for our input, we're basically want to check to see if any of the directions are pressed. And how we're going to do that is we're going to check to see if any of the 4 are pressed. So we got to create some helper functions to help us out a little bit. Inside of your core folder, create a modules file where we're going to add some functions to help us out. Make sure you include using Godot at the top, make your namespace game.core, and then create a public static class called modules. And we're going to have some static functions to help us out. First, we're going to do a public static bool isActionJustPressed. And that's basically going to return the 4 inputs with some ORs in between, checking to see if one of them is being pressed. Once you've created this function, we're going to do the same thing for isActionPressed and isActionJustReleased. That way, anytime we have to check one of these 3 button functions, we can just call this static function and it will give us if any of the 4 are being pressed. Back inside your getInput function in your player realm state, you could check to see if modules.isActionJustReleased. If that's the case, we're going to check our hold time to see if it's greater than our hold threshold or not. If it is, we're not going to turn, we're going to walk. But if it isn't, we're going to turn. So inside of it, check to see if the hold time is greater than the threshold. If it is, we're going to do a player input.emitSignal. And we're going to get our character input.signal name. And we're going to call it walk. It's also technically defined in player input, but the character input abstract class holds this. Else, do a player input emit signal turn. And then what you're going to want to do finally is you're going to want to reset your hold time because you let go of the key. Next, you're going to do if modules isActionPressed. So basically is a button being held down. You're going to do player input.holdTime plus equals the delta. So add that to our hold time. And then we're going to check to see if the hold time is actually greater than the hold threshold. We don't have to wait for the player to let go. We can just emit a walking signal. Go back to Godot and rebuild one more time. And in your roam state, make sure your player input is selected. And again, you can do the state owner if you want, but this isn't going to matter because the state machine is going to assign this for you. Now you can see here, if you run the scene, nothing's going to happen. And that's because we don't have a state declared yet. We have to tell our state machine to actually pick a state. So what we're going to do is we're going to add a class for the player and attach it directly to the parent node here in our scene, the actual player character body 2D. And if you leave the templating on, you can see here that it actually has like a pre-made movement script for you. You can just delete this. All we want to do is we want to have a reference to our state machine. And once we do that, inside of our ready function, what we want to do is we want to call our state machine.changeState, and then we're going to do a state machine.getNode. We're going to pass in state as our generic type, and the name is Rome. Now if we run it, let's see what happens. You can see that the debugger has 2 errors, so let's check those out really quick. Probably forgot to assign something somewhere. Yeah, so the object reference is not set to an instance. That basically just means we forgot to set something. So let's go fix that now. Stop the game and hit rebuild. And I accidentally set the state machine to the player, so I'm going to change that back to state machine. And then I'm going to run the current scene again, and let's see what happens. Okay, you can see that I'm moving, but the animations aren't playing correctly. However, if you look inside the console, you're going to see that the movement is working correctly, 16 by 16, and all the states are getting entered. The player state is getting entered, so I think we're just missing one more signal. Let's go hook that up right now. Inside of our character animation, let's call our character movement, and then we're going to do our dot animation, and we're going to do plus equals and pass in play animation. Let's save that and rebuild it, and then run the current scene. Now you can see the turn animations and the walk animations all seem to be working just fine. The camera seems to be smoothing as it follows. So finally, let's throw the player back into our game manager or our small town and see what happens. You can see here when I start moving around that it actually looks like I'm moving around inside a Pokemon game. This is awesome. And you can see the very first movement we snapped into place. That's because we weren't on a coordinate divisible by 16, but it set the coordinate for us with the snap position to grid. And you can see when we move around here, all the animations are playing properly. Everything seems to be working. So I think this is a natural stopping point for this video. I think in the next one, we're going to take a look at actually creating those collisions and interactions with the world. We'll get that started since the movement seems to be working just fine. Okay guys, thank you so much for tuning back in, and I hope to see you in part 4.